Yo, on this example, we're going to find the absolute extrema of g of x on that interval. So whenever I read this, that makes me instantly think about the extreme value theorem. Alrighty, and the extreme value theorem says that on a closed interval, if a function is continuous, then it's going to have an absolute max and an absolute min, which is what we're going to find. And it could either occur at the endpoints or the critical points. So we're going to start by finding the critical points of G. To find the critical points of G, the critical numbers of G are where G prime either equals 0 or where G prime does not exist. All right, so let's start this party by finding G prime so we can see the critical points. So G prime is going to equal 2 minus 2x to the negative 1/3. Good old power rule, right? And I'm going to make this look just a little bit prettier. I'm going to do a couple things. I am going to write it with a positive exponent. So and I'm also going to factor out a 2. I don't know, it makes it look a little bit better. All right, and then you know what? Now I'm going to make a common denominator so I can easily solve this to find what G prime equals 0. So a common denominator means I'll have to multiply the top and bottom here by x to the 1/3. All right, so I got 2 times x to the 1/3 over x to the 1/3 minus 1 over x to the 1/3. Or cool, and that looks pretty darn good. And I guess I could make it, instead of x to the 1/3, I could write that as the cube root of x. Alrighty guys, so there's my G prime, and I said I was going to find where G prime was equal to 0, and honestly that's why I went through all this mess of simplifying it. So if I want to find where G prime equals 0 or does not exist, to find where G prime equals 0, I'm going to look at where the numerator equals 0. If I want to find where G prime does not exist, I'll look at where the denominator equals 0. All right, and so the numerator, let's go ahead and figure that one out. Equals 1. So x equals 1 will be one of my critical numbers. And down here, x equals 0. So we found two critical numbers. X equals 1 was a critical number because G prime was equal to 0. So that's the reason for this guy. And x equals 0 was a critical number because that's where G prime did not exist. So we've got two critical numbers, and now I've got to find the absolute max and the absolute min. The way I taught you guys in class to do that was to make a table of values. So I refer to that as an EVT table. And when I make an EVT table, I include the endpoints. So I'll do my endpoints in blue here, -1 and 3. And I include my critical points, which were when x equals 1 and when x equals 0. So I'll do 0 and then 1. Cool. So what I need to do now is decide which one of those is going to give me an absolute maximum and an absolute minimum. And the way I'm going to do that is just to compare their values. Just old school, plug them in, see which one's the biggest, see which one's the smallest. A lot of times people say, hey, what do you plug them into? But if we're just looking for the one that gives you the biggest value or smallest value, you just plug them into F. Just see which one's the biggest number, see which one's the smallest. So let's plug a -1 into, or I guess I wrote F, I should have written G. That was the name of our function. Don't go changing its name. So throw a -1 into the G function. And if I threw a -1 in there, that'd be 2 times -1 minus 3 times -1 to the 2/3, which means that's another way to write -1 to the 2/3. Because the 3 is in the denominator, that's the root. So the value there would give me what? -2 minus 3 times -1 squared is +1, cube root it, still a +1. So I've got -2 minus 3. All right, then we can test out the 0 when I throw a 0 into F, and when I throw a 0 into the G function, it's 0. When I throw a 1 into the G function, it's going to give me 2 minus 3, so a -1. When I throw a 3 into the G function, I'm actually going to have to do work. It's going to be 2 times 3 minus 3 times the cube root of 3 squared, which is 6 minus 3 times, cube root of 3 squared, cube root of 9. Gross. While I may not know what the cube root of 9 is, I know that it's a number bigger than 2 because the cube root of 8 is 2. So I know that 6 minus 3 times a number that's bigger than 2, maybe 2 point something, I don't know. I know that this is going to end up being 6 minus a number bigger than 6. So this is going to be a negative number. And I know it's not going to be negative enough to be less than -5. So now I can pick out my absolute maxes and mins. And my largest number here is when x equals 0, I have a value of 0. So that's going to be my absolute max. And then my absolute minimum is going to be when x equals -1, I have an output of -5. So that's going to be my absolute minimum. All right. So the best way to write my answer would be to say that I have an absolute max at 0, 0. I have an absolute minimum at -1, -5. Now, if they asked where your absolute max or min is, then just saying the x value is good enough. But if they ask what the absolute max or min is, then 0 or -5 would be good enough. If you're unsure, just write the ordered pair. On an FRQ, you'll always be right with the ordered pair. Prime was